Do we have first out of 2, 6? Which ones would you like me to look at out of 2, 6?
12, number 2, and number 8.
Okay, 2 and 8. And which other one?
12.
12, sure.
And we do 5.
Yep, we can add 5 to the list as well. Sure, 10. Are there any others? And we've got plenty of time to go through any of these that we need to. Are there any others out of 2, 6 to look at? Sure, we can add 11 to the list also.
We do 7.
Sure, yep, we can look at 7. Is that going to take care of 2, 6 now? Okay. What about 2, 7? And these are those ratio and proportion problems. So which ones out of 2, 7 would you like me to help you set up?
1 and 3.
Sure, 1 and 3. Okay, 8 and 9.
4 and 5.
4 and 5? Sure, yep.
And 13.
Okay. And on these, I'm probably not going to solve them completely through, but I'll make sure we set up the ratio, because that's the hard part, is just figuring out what the ratio and the proportion is. Any more out of 2, 7? 20? Sure. Okay. Any others? Okay, and we can start with these. Now we can add more to the list if we need to. So let's now look at 2.6. And we're going to begin now with question number 2. So we need to figure out if this is an area problem or if this is a perimeter. Measuring a garden for tilling. Okay, now, when we measure how much we're going to use for tilling, we're going to till up the whole thing, right? So we're going to use the area. Because when we talk about a garden, we talk about how many square feet this garden has in it. So in this case, when we're measuring a garden for tilling, we're going to till the entire part. We're not just putting a fence around it. If we were putting a fence around something, that would be an area. Sorry, perimeter, right? Perimeter is adding up all the sides. When we talk about tilling, we're going to be digging it all up, and so we're looking at the area. So the first one, when we talk about measuring a garden for a border fence, we're going around the garden with a fence. That would be perimeter. When we talk about tilling it up and digging it all up, that's going to be an area. That's like how much flooring you have in your house. Flooring is measured in square feet. That's the same as tilling up a garden. Same type of concept. How much is there? So number 1 would be perimeter. Number 2 would be area. Because perimeter is adding up all the sides, and area is just how much you have. So question number 2 would be area. Next, we're going to look at question number, it looks like 5. Okay, now question number 5 is an angle problem. Now, when we talk about angles, there's 3 different scenarios. They can equal each other, they can add to give you 90 degrees, or they can add to give you 180. Now, 90 degrees, like that, 180 is a straight line. So what is this one? This one's a straight line. So that means those 2 angles are going to add together to give you 180. So for question number 5, you're just going to add them together. And that's going to then give you 180. Because our picture looks like this. And there's x and there's 3x over here. So we're going to add those together to make it equaling 180. So then we've got 4x equals 180. We're going to divide by our 4. And that should give you, I believe, x is 45, I think. Let me double check and make sure. You're always better off using calculator to double check than to make a mistake. But I believe it should be 45, and it is. Now, that is not my final answer, though. Okay, that is not our final answer. How do we get our final answer? Well, our final answer, we're going to have to plug that back in, and we're going to have to get our two angles. So the first one, we're going to plug it in here for x, and so that means that this one is going to be 45 degrees. So there's your first answer, 45 degrees right here. And what about the other one? All right, well, the other one, we're going to plug in that 45 again. And 3 times your 45, that should give you what? 135, I believe. And that's going to be your second answer. So those two would be your answers. We do not just stop at x. All right? Once you have x, you have to plug it back in. And that's where students make mistakes. This is a good type of test question. Something simple like this to solve. You're going to have to remember when you find your value of x to take it and plug it back in. But this is something you're probably going to see on your next exam. Question 8. Question 8 is another angle problem. X plus 9. So this is what we've got for question 8. Well, what do we know about these? These form an X. And when they form an X, that means the left-hand side is going to equal the right-hand side. So these are going to equal each other here. All right, so I'm going to write up the equation. You're going to solve it on your own, and you're going to finish it out, just like what we did on the last one. So your equation is going to be 2x plus 48 equals 5x plus 9. So what you're going to do is you're going to solve for x and then find the measure of each angle. So you're going to have to finish this one out. So you've got your equation. They're set equal. You'll solve for x, and then you'll plug it back into each side, and the sides should be the same. So when you find x, x is not going to be your answer. You'll take it and you'll plug it into the left-hand side, and you'll plug it into the right-hand side. Those then should be the same at the end. That sets that up, and you should know how to finish it from there. Same thing with question 10. Okay, question 10 is another vertical angle problem. And you're going to solve it the exact same way that you solved the last one. So that's 2x plus 51. And the other side is 5x plus 9. What do we know? Okay, these form an x. When they form an x like this, that means the left equals the right. So those are going to equal. And your equation would then be 2x plus 51 equals 5x plus 9. You're going to finish this one on your own, so you're going to go ahead and solve for x. And then find the measure of each angle. Okay, so you'll solve that for your x. X is not going to be your answer. You're going to have to take that, plug that back in. And I think we may have forgotten question 7, so we'll go back and get that. I think I just looked right past question 7, so we'll go back and pick that one up right now. Okay, so this is what we've got. And this is question 7. And this is a literal equation. So what do we want to do? Well, we want to solve for the specified variable. And in this case, we're going to be solving it for the r. So we want r all by itself. Now, we move things across by using addition and subtraction. So what I always like to do is find our variable first, and we'll put a box around it. So there's our r. Now, I want to get that r by itself. So to get the r by itself, I need to remove the s. So I'm going to go ahead and subtract that s off from each side. Then that leaves me with a plus b minus s equals r. Now, when we solve it and write out our answer, we normally want the r on the left-hand side. So we can just flip these around, and we can rewrite this now by just moving it around as r equals a plus b minus s. So there's going to be your final answer. Now, how do we know we've finished it? Well, we should have solved it for r. What does that mean? That means the r is on the left-hand side, and the r is all by itself. So I just moved that s over with subtraction. And then I rewrote it so that the r was on the left-hand side. And you'll see more of these in intermediate algebra, but they'll be a little bit more complicated. But whatever we learn in this course, you build upon and you use again in intermediate and college algebra as well. So we should now be ready for question 11. So we've got 11 and 12 left to work through. And these are going to be requiring us to use the formulas in the back cover of our textbook. So let's look at question number 11. We're going to read it through. Then we're going to see what we've got. We're going to find the correct formula, label the pieces that go under the formula, and finish the question. A circle has a circumference of 44 pi meters. Find the radius of the circle. So when I read that, what am I looking for? Well, I'm looking for a circle. So let's go to the back cover of our textbook, and we're going to be using the circumference and the radius. So let's go to the back cover, and we're going to find our circumference here. So here's our formula for circumference. And there's two formulas. This one is for the radius because it has an R. This one is for the diameter. R is once the radius, so we're going to use this top formula here. So let's write up our formula, label our pieces, and then plug it all back together. So what's our formula? Well, our formula is C equals, if we read it here, 2 pi r. Now, C is going to be the circumference. And so when we read this question, it looks like the circumference is what? 44 pi. We're going to keep the pi along with it. So the circumference, which is C, is that 44 pi. So now we're going to fill this in. So now we've got 44 pi equals 2 pi r. Now we could use our calculator in that 3.14, but we don't need to do that. We can actually divide and get rid of that pi. So we want to find r. Right? We want to find the value of r. So the 2 pi is related to the r by multiplication. So what's going to undo my multiplication is division. So I'm going to go ahead now and divide both sides by that 2 pi. And that's going to clear there and there. And 44 divided by 2, well, 44 divided by 2 is going to be 22, and the pi's, they can cancel. And so that gives you 22 equals r. So we're going to rewrite that with the r on the left. So our r equals 22. And what are our units? Well, it says the circumference of a circle is 44 pi meters. So we found our radius. Radius we can measure. Radius will also be in meters. So your answer on that one would be 22 meters. And those pi's, they cancel out. So we determined what formula to use. We reread the question to find the values. We plugged the values in. We solved it. Those pi's canceled out. And then we made sure that we labeled our answer. Because that circumference, it was in meters. So that means your radius must also be in meters. Now we're going to move on, and we're going to look at question 12. A pie-shaped triangular lakefront lot has a perimeter of 1,700 feet. One side is 100 feet longer than the shortest side, while the third side is 400 feet longer than the shortest side. Find the lengths of all three sides. Now, we can look up the formula for a perimeter, or you can remember that perimeter, no matter what the figure, no matter what it is, square, rectangle, triangle, perimeter is always going to be the sum of the sides. And this is question 12. Thank you. If you wouldn't mind closing that door, that'd be great. So we're looking at the perimeter, and the perimeter is going to be the sum of all the sides. And when we talk about a triangle, this triangle is going to have three sides. And we've got the longest side. We've got a middle side. And we've got the short side. So these are our three sides here. So three sides for this triangle. Let's try to find our sides here. So we're going to read it again, make sure we got all the pieces labeled out. This 1,700, that's your perimeter. We'll deal with that later on. It says one side is 100 feet longer than the short side, while the third side is 400 feet longer than the shortest side. Okay, so one side is 100 feet longer than the short side. So that's going to be your middle side, and that's going to be your short side plus 100. Okay, that's going to be your middle one. What else do we know? The third side, which is going to be your longest one, the third side is 400 feet longer than the shortest side. So that's going to be your longest side, and that's going to be the short side, plus now the 400. Which one do we not know? The short side. So that's the unknown, so that's going to be the variable x. So we have the longest side, we have the middle side, and we have the unknown short side. Now we can rewrite this with variables. So the longest side, rewriting, is going to be x plus 400. The middle side is going to be x plus 100. And the short side is the unknown component, so that's going to be our x. Is everyone okay with how I labeled it? Right, so one of them has got to be x, and we don't know the short side. I called this one the longest side because you're adding 400, and I called this one the middle side because you're only adding 100. So we now have it all in terms of the variable x, and we're looking at our perimeter. So for our perimeter, we have the short side plus the middle side plus the longest side, and that's going to equal the perimeter. Because the perimeter is the sum of all the sides. And we can now fill it in. So the short side is going to get filled in with an x. The middle side is going to get filled in with an x plus 100. The longest side is x plus your 400. And finally, the perimeter, well, that is given in the actual problem itself. And in the problem itself, it says the perimeter is 1700. So that's going to be your equation. So is everyone okay with that? So perimeter is 1700. Perimeter of any figure, it doesn't matter what it is, rectangle, triangle, square, any figure, trapezoid, any figure has a perimeter that is just simply the sum of all the sides added together. You can look it up, but if you just remember perimeter add the sides, that's going to be the easiest way to work this one out. Let's go ahead and finish it out, and we can answer our question here. So it looks like we've got 3x when we add those together. 100 and 400 makes it 500. We'll move that 500 over with subtraction. That leaves me then with 3x equals now, I believe, 1200. We'll divide by our 3. And that should give you then x equals now, I believe, 400. So that's what we've got for a value of x. Now, is that our final answer? No, we've got to go back. We've got to fill it in. So when I fill it in, okay, our first one, shortest side is x, so that's going to be 400. And what do they use for the measurements? Feet. So that first one is going to be 400 feet. That's your shortest side. We add 100, and that makes the next one 500 feet. That's your middle side. And the last one, what's that longest side going to be? 400 plus another 400. That makes it 800 feet. And those are your 3 answers there. And you can double check, because if you add those together, what do you get? Well, 400 and 500 makes it 900. Add 800, you get the 1700, and that's your perimeter. We answered the question by getting all three sides. We went back and we labeled them with the correct units of measure, because if the perimeter is in feet, that means everything else is also going to be in terms of feet. So that now should finish up 2-6, unless we have any other questions. Did we find any others out of 2-6? Okay, well, then we'll move on now to 2-7. Two 7 is ratios and proportions. And so a lot of these, I'm not going to be solving them out completely. I am going to be setting them up. Some of them I'll solve out, but the majority of these, I am just going to set up the ratio and let you solve them out. And this is 2-7. We did a couple of these in class last time, and this is using the Consumer Price Index, and this allows you to adjust prices from year to year based upon inflation. So we've got our table, and it says use the Consumer Price Index in the figures in the table below to find the amount that would be charged in 2001 for the same amount of groceries that cost $168.10 in 1995. And then we're going to round it to the nearest dollar. So we need to set up a ratio. It doesn't matter whether we do the price on the top or the index on the top, but you've got to make a fraction. We're going to go ahead, I think, and just use the price over the index, but you could switch them around. Just make sure you know which one is which. So we're going to make our ratio as the price over the index. And then we've got 2 years. We've got 1995. And we have 2001. These are going to be equal with our index here. So what do we know? We're going to start filling it in. Use the Consumer Price Index, figures in the table below, to find the amount that would be charged in 2001 for the cost of the groceries that cost $168.10 in 1995. So the groceries cost $168.10 in 1995. That's our price. Okay. We don't know the price of those groceries in 2001. So we're going to use an X there. Now what goes down below is our index values. So now we've got to go back to our table. We're going to find our index values here. So if we look at 1995, our index is 152.4. And if we go down to 2001, our index is 177.1. You could have put the index on the top. It wouldn't matter, just as long as you set up this ratio. I am not going to solve it. I'm going to leave it for you to do. So what would you do? You would simply cross multiply. I'll write up the equation just so we have it on this one. So you would simply cross multiply. So then that's 152.4 times x, and that's going to equal 168.1 times 177.1. And you can finish it from there. So you'll solve that out. Find your value of x, and x is going to be what that grocery should cost in 2001. 1. So it should be a slightly higher number because inflation hasn't changed that much, but it will make it, probably $5 or $10 more. These are all pretty much the same. It's just setting up the ratios correctly. Okay, so question number 3. The ratio of the distances a pitching wedge and an 8-iron will drive a golf ball is a 4-to-5 ratio. If a golfer averages 92 yards with the pitching wedge, how far should she average with an 8-iron? So first off, we have to make sure we've got our ratio set. And what do we know here? The ratio of the distances of the pitching wedge and the 8-iron. So the wedge is going to go on the top. The 8-iron is going to go below. The one that's listed first goes on top, and that's the wedge. And the 8-iron goes below. Now, what is that ratio? When we read this question, it says the pitching wedge and the 8-iron will drive a golf ball with a ratio of 4-to-5. So that means the ratio is 4-to-5. So your wedge is 4, your 8-iron is your 5. Now we need to find our distances. So if a golfer averages 92 yards with the pitching wedge, so 92 yards with the pitching wedge, that's going to go here. Okay, because that's how many yards you can do with the pitching wedge. So it goes on top. What do we not know? Or what do we want to find? We want to find that average with an 8-iron, and so that's our unknown, and so that's going to be the X there. So this is our ratio, and this is the golfer here. So that's our golfer, and that golfer can do 92 yards with a pitching wedge. We need to find how far she can go with an 8-iron, so that's going to be our X. And I think you can finish it from there. So to finish it, you're going to do exactly like you did the last one. You're simply going to cross multiply. Solving them is usually not the difficult part. The difficult part is always in that setup. Very, very similar. Questions next. Again, it's just making sure we set these ratios up correctly. So question 4 is next here. A line from the top of a cliff to the ground passes just over the top of a pole 9 feet high, and it meets the ground at a point 8 feet from the base of the pole. If the point is 69 feet from the base of the cliff, how high is the cliff? And we want to round it to the nearest unit. So let's see what we've got. And we're going to try to draw a picture so we can kind of visualize what we've got. So we are on a cliff, and we're going to be passing a line down. So we're on the top of the cliff here. So this is our cliff. And we're going to pass a line down or a rope down. And it's going to meet the ground somewhere over here. So this is our cliff. And this is going to meet the ground somewhere here. Now, when we pass this rope down to the ground, on that angle, it's going to touch a flagpole. And that flagpole is right here. And that flagpole is 9 feet high. And its shadow is 8. So this is what we've got. Now we need to figure out how we can set up our ratio. We also know that the point is 69 feet from the base of the cliff. So that means the distance from here to the end here is going to be 69. So that's what we've got. So this is our picture here. Now, we need to set up some ratios so we can solve it out. What we want to find is we want to find the height of this cliff. And we don't know what the height of that cliff is, so we're going to use an x there. Now, when we set up our ratio, we want to see how they relate. So if I look at my picture here, the heights go together. So the heights are going to be x for the unknown cliff, and that pole is 9. So that's our ratio there. Now, what do we know about the length? So this is the heights. And this is the cliff here. This is the pole down below. Okay, so that's how we're going to set up a ratio, the cliff over the pole. So the height of the cliff is unknown. The height of the pole is 9. Now, what do we know about the lengths? Okay, well, the lengths of this shadow, okay, when we look at the cliff, this cliff has a shadow that is 69 feet long. So that's going to go there, okay, right, go to that piece. And what about the pole? How long is the shadow for the pole? Well, if I look at my triangle again here, how long is it going to be? It's going to be that 8. And now you can just simply cross multiply and solve it out. Okay. We set it up as a ratio. Here's the cliff and here's the pole. Height of the cliff is unknown. Height of the pole is 9, feet, I believe. Let's see here. Yep, 9 feet. Okay, so it's in feet. So cliff is unknown, pole is 9 feet. Those go together. They're the vertical part, the heights. What about the lengths? Well, the length from the cliff to where it touches the ground, that's 69. What about the pole? How long is the shadow of the pole? 8 feet. So it goes down below there. You just have to make sure that you set up the ratio correctly. So I looked at the cliff and compared it to that pole. Those made triangles, and we could see how the triangles are similar. And that, by the way, was question number 4. And I'm going to leave that for you to finish. Question number 5 is very, very similar again. Just a little bit different. Question number 5 is another shadow problem. So a tree casts a shadow that is 19 meters long. At the same time, the shadow cast by a 39 centimeter tall statue is 89 centimeters long. Find the height of the tree. Round the results to the nearest unit. So let's try and work through this one here. We've got a tree and we've got a statue. So we're going to draw our two triangles here, and they form a shadow. So our tree is going to be here, and then our statue is over here. Okay, and what do we know about this tree? Well, it says a tree casts a shadow that is 19 meters long. So this tree has a shadow, the length of that shadow is 19 meters long. Do we know the height of that tree? Does it tell us at all? No, we don't know that. So that's going to be our X there. So this tree casts a shadow. What about the statue? Well, the statue is 39 centimeters tall. So that's going to go here. And that statue has a shadow that is 89 centimeters long. Okay, so the shadow cast by a 39 centimeter tall statue, which is here, is 89 centimeters here. So these are going to be set up as our ratio. And let's look at it as the tree over the statue. And we'll look at the height, and then we'll look at the shadow. So when we set up our ratio, we've got our tree over our statue. What's the height of this tree? Well, height of this tree, we don't know. So we're going to call that X. That tree has a shadow that is 19. What about the statue? Statue is 39 centimeters tall. So that's going here. What's the shadow of that statue? 89. Okay, and then you can solve it from here. Now, where would you use this as an application? Well, this is actually used a lot in law enforcement when they try to figure out the height of an individual. If you've got a photograph and you've got a building that casts a shadow, and you've got a suspect walking on the street, and he also has a shadow, you can figure out how tall that person is by measuring the shadow, looking up how tall the building is, and then comparing it to the shadow of the man in the photograph. You could set up a simple ratio and you could figure out how tall that person is. So if you got a photograph of someone walking through a building and you know how tall this building is and it has a shadow, and you've got a person walking down and they also cast a shadow from the photo, you could get a rough idea how tall this person is. So if they're in Chicago and there's lots of buildings and you're trying to figure out how tall this suspect is, you could look at the buildings, look them up, the blueprints, figure out how tall they are, set up your ratio, and you could figure out with a pretty good degree of certainty how tall that person is. So law enforcement uses this a lot. Computers do it for us now, but they do the same process. But it wasn't that long ago, 50, 60 years ago, when if you had a photograph, you would have someone measure that photograph, calculate your ratios, and try and determine approximately how tall that suspect was. And that's how they do it. That's how they come up with the height. Just kind of an interesting side note there. So this actually does have an application. Okay, so that was question number 5. And it looks like the next one is going to be question number 8. Okay, so question number 8. So question number 8 is a percentage problem. 39% of what number is 68? Okay. Now, what does is means? Is means equal, right? Remember that? Talked about that a lot. 39%, we need to turn this into a decimal. So 39% as a decimal, what would that be? 39% as a decimal, well, that would be 0.39. Now, we don't know our number, so x is going to be the number. Okay, so x is going to be our number. Is means equals, so we've got 0.39. We're going to have to multiply that by our number, x, and that is going to give us 68. And it should be a larger number. You could also do this by dividing, but this is how we actually set up an equation. And your answer should be bigger, because 38% of some number is 68. That means that number is going to be larger than your 68. We can go ahead and finish this out by simply dividing. Percentages always have to be linked to a variable or a number. So you can't just leave that 0.39 by itself. It has to be linked with something through multiplication. So we'll go ahead and divide this out, and we should get a bigger number. So 68 divided by 0.39. Okay, and what does it say to do? How far do we need to round here? Okay, we're on question 8. We'll just go to the nearest number. So it looks like it's going to be about 174. So it's about 174. When we divide, we get that x to come out to be about 174. We'll just go to the nearest number. Because when you divide them, it's not a whole number. And it gives you, can't see that very well. It gives you that. Okay, so we just want the nearest number. So we're going to say that's about 174. And that makes sense because we want 39% of that number to give us 68. So it's got to be bigger. We've got a couple more to set up. So question 9 is next. 2 more of these after this one. So question 9. Another shadow problem. A church steeple casts a shadow that is 105 feet long. At the same time, a 9-foot post, that's going to cast a shadow that is 5 feet long. How high is a steeple? And we're going to round to the nearest unit here. So what we're going to look at is our pictures again. So we've got the church steeple. And that church steeple is going to cast a shadow. We've got our sun on it. And that church steeple has a shadow that is 105 feet long. We don't know how tall the steeple is, so we're going to call that x, right? Because this, what happens is you get a shadow here. Like when you have the sun up here, it makes a shadow on the ground. And we can compare this to a 9-foot tall post. So we've got our post over here, and that post is 9 feet tall, and it casts a shadow that is 5 feet. So there's our ratios again. So if you had a photo, and let's say you had an old photo and you wanted to figure out, well, how tall is this church? And you could see that there's a 5 or 9-foot post in the ground, because you know that's 9 foot. You could then measure it from the picture, find out what those shadows are, and then use that to estimate how tall the church would be in that photograph. So let's go ahead now and set up a ratio. It doesn't matter which one goes on top, so let's just put the church on the top and the post down below. And we're going to look at the height and the shadow. So here's our pictures. The church. Okay, the church, when we look at the height of the church, that steeple, we don't know. So we're going to call that X. How high is our pole? 9 feet. Now we're going to look at the shadow. What's the shadow of the church? 105. What's the shadow of the post? 5. Cross multiply. And then you can finish it. That's how you set up that ratio. You just want to make sure it's division. Once you get the ratio, it's very, very simple to solve. The hard part is always setting up that ratio. The easy part is solving it. Question 13. So this one's going to require a lot more algebra. And we'll take a break after we finish up question 20. So we've got 13 and 20, and we'll take a short break. So question 13. We need to find our variable. Solve for the variable. So our ratio is 4r minus 3 over 9 equals r over 8. And I'll work through about half of this one for you. So we'll work through about half of this together, and then I'll leave the rest of it for you to finish. How do we clear out these fractions? Well, they're equal to each other, so we can simply cross multiply. So simply cross multiplying. Doesn't matter which one goes on the left or the right. I'll just go ahead and put the 8 times 4r minus 3 on the left, and that's going to equal the 9r on the right. But it doesn't matter. You can put them in either side. You just make sure you set up that ratio. I'm going to do another step. I'm going to go ahead and distribute that 8 through. And we've got 8 times 4. That should be a 32. So that's going to be 32r minus 8 times 3. That's a 24, and it's negative. And that equals 9r. I think you can finish it from here. So all you're going to have to do is just simply move that 32r over, then divide, and you'll find the value of r. So you've solved a lot of these before. So this is not going to be anything new, and you should be able to solve it. The last question that we asked about was question 20. And what we're doing for question 20 is we're going to try to find the best buy and give the unit price. So for question 20, we need to set up our ratios again. So we're at the store, and we want to compare these two brands of, I don't know, maybe it's ketchup, maybe it's tomato sauce, whatever it might be. We want to compare them. So there's two brands, and they're pretty close in size, different prices. We need to figure out which one's actually going to be the better buy. And how do we do that? We do that by taking the price and dividing it by the weight, in this case, ounces. So our ratio is going to be price per ounce. So that's price on the top and ounce down below. We'll calculate both of these out, and then we'll figure out which one's going to be the better buy. So we'll do brand A. So brand A is 340 over 20. And we'll just get this to the nearest cent. It doesn't say exactly how far to go, but I think the nearest cent should be good enough. So we'll just go out to the nearest cent. You can go out to the nearest tenth of a cent if you want as well, but we'll just go out to the nearest cent. So we'll just go ahead and divide these. And we'll figure out our unit price, cost per ounce. So we've got 340. We're going to divide that by our 20. And this comes out to be 17. 17 cents per ounce. We want the one that is cheaper per ounce. So what about brand B? Well, brand B, again, same ratio, price over the cost, or sorry, price over the size, the ounces. Brand B cost me $4.32, and it holds 24 ounces. So let's divide it out and see which one's going to be the better buy now. So 432, divide that by your 24, and that comes out to be 18 cents per ounce. So which one's going to be the better buy? Well, the better buy is going to be brand A. So brand A is the better buy. Not by much, but it is a little bit cheaper per ounce. Right? You want the ones smaller, and so brand A is just a little bit cheaper per ounce. We're gonna go ahead now and take a short break. We'll come back and we'll start then to 8. So let's take a short break, and we'll meet back here at, let's say, 9:40. So meet back here at 9:40, and then we'll begin looking at 2-8.